Hello viewers, this is Prakash Chandran and my batchmates are Mohammad Atir Alam and Mohammad Irfan. Our project is about experimental investigation on selective laser melting of stainless steel SS316L. Our internal guide is Professor S. Sekar, Mechanical Department of Weltech Institute. The abstract of the project is the selective laser melting is an additive manufacturing technique in which a part is built up in a layer by layer by melting the top surface layer of a powder bed with a high intensity laser according to 3D design data. In this project, we can conclude the mechanical properties like tensile strength, elongation, Young's modulus, and hardness for SS316L. The objective will be the study of mechanical properties of the sample produced by SLM and tensile strength, yield strength, hardness, so that we can compare the standard sample made by SLM with the sample made by normal process. First, I will explain the introduction. The laser source selectively scans a powder bed according to the CAD data of the part to be produced in a SLM machine. The high intensity laser beam makes it possible to completely melt and fuse the metal powder particle together to obtain almost fully dense parts. Successive parts of metal powder particles are melted and consolidated on top of each other, resulting in near net shaped parts other than surface finishing. Additive manufacturing is a class of layer by layer manufacturing technique that can fabricate highly complex components from a three-dimensional CAD model. This model is sliced into 2D slices with a certain layer thickness, and subsequently each layer is built up by adding material. This is the explanation of stainless steel SS316L. The grade 316 is the standard molybdenum bearing grade stainless steel. The molybdenum is the main source which gives 316L better overall corrosion resistant properties. It is extensively used in heavy gauge welded components. The austenitic structure gives excellent toughness even down to cryogenic temperatures. The types of resistance will be corrosion and heat. Corrosion is the damage caused by oxidation or other chemical reaction in the substance of the sample. Therefore, this sample is fully resistive to corrosion. As well as thermal resistance is a heat property and a measurement of a temperature difference by which an object or material resists a heat flow. It is a reciprocal of thermal conductance, and it is also resistive for heat. The machining will be the 316 stainless steel tends to work harden if machined too quickly. For this reason, low speeds and constant feed rates are recommended. 316L stainless steel is easier to machining compared to 316 stainless steel due to its lower carbon content. These are the literatures where our guide guided us to go through, and we learnt many that we didn't even see. And in the problem definitions, I will show you the sample diagram and its dimensions, and finally the calculations for finding the tensile strength, load at failure, mass and weight of the sample. This is the overall diagram, that is, which shows schematic overview of a SLM machine and building direction of a test sample. The first one is schematic overview of a SLM machine, in which the sample is made by layer process in SLM machine. Second one is the building direction of test samples. We can either build in y-axis direction, or either we can build in x-axis direction, which is vertical or horizontal. Here we did in horizontal direction. This is the sample diagram of the sample, and expected outcomes will be overall length, which is 85 mm, distance between shoulders is equal to 25 mm, grip section is equal to 30 mm into 2 because of 2 grip sections, width is equal to 3 mm, area of the rectangle is equal to 50 mm. Let's see if we can get the expected outcomes. This is the tensile strength testing machine located in SLM Lab in Tech Institute. This is the sample made by SLM. This is stainless steel 316L. One is tested in Tech R&D Institute and one is from Microlab. This is the line diagram of the sample which shows us all the each and every dimensions. This is the CAD model, that is CAD diagram of a sample. Let's see the conclusions. The maximum tensile strength of the rectangular area. To find the maximum tensile of the rectangular area, we need area of rectangle and tensile strength rectangle. The formula of rectangle is equal to length into breadth. The formula for tensile strength is equal to load at failure divided by area of rectangle. Therefore, area of the rectangle is equal to length into breadth. Here, the length is 30 mm and breadth is 10 mm. So, area of the rectangle is equal to 300 mm square at the grip section and 72 mm square at the shoulders. Tensile strength is equal to load at failure divided by area of rectangle. Load at failure is equal to 13 kN. Area of rectangle is equal to 72 mm square, which is at the shoulders. Therefore, tensile strength of the sample is equal to 13 kN divided by 72 mm square, which is equal to 180.55 Newton per mm square or 185.55 megapascal. And for grip section, 13 kN load at failure is equal to 13 kN and area of the rectangular flat bar is equal to 300 mm square. So that which is equal to 43.33 Newton per mm square into 2 because of 2 grip section, which is equal to 86.66 megapascal. The Rockwell hardness test of the sample is selective loads is equal to 100 kg. Hardness of the sample B1 is equal to 887 Rockwell hardness number and B2 equal to 881 Rockwell hardness number. Distance of elongation of the sample is equal to 7 mm. Overall length of the sample is equal to 92 mm. Value of width after elongation is equal to 2 mm at the breaking point. As volume is equal to mass into density, but density of the material SS316L is equal to 7.99 gram per centimeter cube. Therefore, yield strength is equal to 60% of ultimate tensile strength, which is equal to 267.21 into 0.60, which is equal to 160 is equal to 160.32 megapascal. This 267.21, that is ultimate tensile strength, is from the sample tested from SLM Lab, Tech R&D Institute. And then to find the mass of the sample, we know mass is equal to volume by density. Therefore, for case 1, volume of grip section, we know the volume is equal to length into width into thickness for flat bar, which is equal to where length is 3 cm, width is 1 cm, thickness is 0.6 cm. So by multiplying them, we get 1.8 cm cube into 2 because of 2 number of grip sections, which is equal to 3.6 cm cube. Case 2, volume of shoulders. Here, volume is equal to length into breadth, length into widthness and thickness, where 2.4 centimeter is the length, 0.3 cm is the width, 0.6 cm is thickness. So we get 0.43 cm cube, which is similar to 0.5 cm cube approximately. Total volume is equal to volume of group section plus volume of shoulders, which is equal to 3.6 plus 0.5 cm cube, which is equal to 4.1 cm cube and 0.035 meter cube. Therefore, mass of the sample SS316L is equal to volume by density. So volume is equal to 4.1 cm cube and density is 7 by 7.99 gram per centimeter cube. By dividing them, we get mass is equal to 0.513 gram. The technical data of the stainless steel SS316L. The nominal composition. Here we get every each and every material involved in the SS316L. This is the mechanical properties, which are universal standard properties for tensile strength, yield strength, elongation, hardness for SS316L, and here are the physical properties. This is the Microlab test parameters, where we get yield strength is equal to 574 megapascal and ultimate tensile strength is equal to 689 megapascal, and percentage in elongation of 4 gauge length is equal to 36.50%. Here we compared the value taken from SLM Lab, Weldtech R&D Institute, and Microlab value and standard value. This is the proposed methodology. First, we selected our topics. Second, we selected the materials. And third, we designed and dimension of the sample by using CAD software. And fourth, we did 3D printing of the sample, and next we tested our sample and compared, and finally presentation. The results will be we determined the mechanical properties like tensile, hardness, and we found the theoretical mass of the sample. This is the time chart where it took maximum 3 to 4 months. Thank you.